This is it. I mean, you're at this point in your lives here in chemistry, you're just innocent babes. After Monday, after Monday's class, you will be worldly wise. This is the last day of innocence. This is the last day. After Monday, you will know how to write and name ionic formulas. Yes, yes. It won't be the same after Monday. It'll never be the same. I am so excited for you. Okay, today I'm going to do what volleyball players do, and that is, just set the ball. So set it so it's just over that net, just inviting, saying, hey, spike the ball and smash that opponent right in the face, and maybe break her nose and make her cry. Okay, so I am going to set the ball for you volleyballers today, metaphorically, so that on Monday you spike that sucker and make a point. Yay. So today we're going to talk about the differences between atoms and ions, because on Monday we're going to learn how to write ionic compounds. Might be good to know what an ion is. And I know there's some bad English here. I need to fix it. I will show you how you can use the periodic table to give you very important information in order to do what you need to do on Monday. All right, let's review. What are the two most important particles in an atom? I know there are three, but the third one, the latest one that we discovered, not very important. Phobos. And protons and electrons. Why? Because protons are positives and electrons are negative. Okay? So, if we say an atom is neutral, what do we mean by that? Marie. It has the same number of positives and negatives. The eternal battle between positives and negatives is dead even. No one's going to win this battle. Zero chance. So, what are ions? Ions are atoms that have either gained or lost electrons. Atoms that have either gained or lost electrons. We call them ions. Chemistry is so abstract. So one of the best ways to successfully navigate yourself through chemistry is to create metaphors. Sometimes the metaphors work, the ones I will create for you. Sometimes they will work, sometimes they don't. This is one that works pretty well. Okay? I think your dads will appreciate this one. Your moms maybe not so much. Let's do it. The atoms that like to give electrons, they like to give gifts and give diamond rings and give stuffed animals and give and give and give. Those are the guys, right? They're the metals. Metals are atoms that love to give electrons. Actually, they're not happy until they've given an electron. Okay? Non-metals, I like to think of non-metals as being girls. Okay? It's like, hey, where's my French fries? Give me my French fries. My wife is like that with coffee. Where's my coffee? Oh, and I run because I don't want a grouchy wife. Okay, she gets grouchy in the morning, so I run to get her coffee. I am the metal, and I'm always giving her things. She's the non-metal. She takes things. Okay? Believe it or not, it's kind of like that way in the world, in the chemical world. Okay? So if you're a negative ion, a girl, what do you why are you negative again? Why are you negative? Because you take what? Negative things. Guys, you cannot give a proton. If Morgan was to give one of her protons away, we would look and we would notice that it's not Morgan anymore. Morgan is somebody else. Morgan would change her identity by giving a proton away. Okay? Morgan would lose her identity. You cannot gain or lose protons. No, 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 no. You gain or lose electrons. Okay? Metals like to lose electrons. Nonmetals like to gain electrons. So nonmetals tend to become anions, or negative ions. They take electrons. Give me the French fries. Give me the coffee. I want. Negative. What about when they lose electrons? Why do they become positive ions? Positive ions. Why? Oh, anybody? Marie, again. They're losing negative things. I had plenty of French fries. My roommate, my best friend, Mike, he realized that I had fallen in love when he and his girlfriend were eating with me and my wife at the time. Well, she wasn't at the time. My girlfriend at the time, my wife now. And he looked over and he said, "Vidal, you're in love." I go, "Why? Why?" "She's sharing your French fries." I'm going, "Yeah, I let her take my French fries. Because if he ever tried to take my French fries, I used to take a fork to his hand. My French fries! Mine!" But Jackie was like, "Oh, you can take my you can take them all. I'll just stare at you. You're pretty." Guys are like that. When we fall in love, we're willing to share. Normally we don't share. But when we fall in love, we're willing to share. So, why are positive ions positive? Because they lose their electrons. They lose their French fries. So, what do we call positive ions? A cation. There is, just in real life, when my wife and I got married, what happened to my name? What happened to my name? What happened to my name? My name stayed the same. In the same way, metals, when they lose electrons, their names stay the same. Now, you may think that, I'm just old-fashioned traditional, but that's just the way we did it. What if you're a non-metal and you gain electrons? Your name changes. It changes to IDE. Anion's name changes to IDE. Anion's names change to IDE. So if you're a non-metal and you gain electrons, you change your name to IDE. So, if you were to say, "Mr. Marino, I have some chlorine for you. Would you like it?" I would go, "Why are you talking like that?" But to answer your question, did you say chlorine or did you say chloride? Because if you said chlorine, stay away from me. Why are you messing with that stuff? That stuff is dangerous. See, chlorine in its natural state is going, "I need an electron. I want an electron. Somebody give me an electron." Bam! You're knocked out. She takes your electron, and now she's going, "I am now okay. I have an electron. I've changed my name to chloride. Everything is beautiful." "Oh, you've got a black eye. Why? Who hit you? I'm so sorry." Fist pump. There. Do you see the difference between chlorine and chloride? Chlorine is nasty. It is dangerous. Bad. Chloride is happy. It's good. It's safe. It's cheerful. It is just like that. Now, why? Why is it like that? There's a lot of whys here. First of all, why is it happier when it gains an electron? Why was it so unhappy when it lost, when it had all of its electrons? Why does it gain one and now it's happy? Why not two or three? Well, you're not mature enough to understand that. I'm not going to tell you. I'll make a deal with you. If you survive next 9 weeks, which is the hardest 9 weeks of the whole year, if you survive the next 9 weeks, I will let you know in January. Okay? All right, Beth? Is that a deal? You survive the next 9 weeks, and I'll let you know in January. For example, look, oxygen. Why is oxygen happy with 2 and not 1? You don't know. I know. You don't know. And you won't know until January. Why is nitrogen, whose name we now changed to nitride, why is nitrogen happy with having taken 3?
We don't know.
But you will if you survive the next 9 weeks. All right. Well, if you don't survive, then you'll just have to go to they'll probably put you in a study hall, and you'll just have to sit there the whole time wondering. Okay. So when sodium loses electrons, the name stays sodium. Yes, Max.
I was just going to ask if, which one needs to gain the most electrons to be happy with element?
Gain the most? Probably nitrogen.
Or
-3 is probably it. Magnesium. If it loses 2 electrons, why will it lose 2 electrons instead of 1? You'll find out in January. But notice the name does not change. But aluminum will lose 3, and its name doesn't change. But when we get to chlorine, its name changes to IDE. So when you gain electrons, your name changes. Yes?
Do some elements not change? Like, I've never heard of aluminide.
That's because aluminum always gives electrons.
So some elements don't gain them and only give them?
Well, let's talk about that. How do we know whether a cation will lose 1 or 2 or even 3 electrons? Or whether an anion will gain 1 or 2 or 3? Your best friend will tell you. No, seriously, your best friend. Oh, I forgot to tell you. You're in chemistry. You should have your periodic tables and your calculators out. What important piece of information can the periodic table easily tell us? Whether an element is going to be a giver or a taker, a guy or a girl, a cation or an anion. How do you do this? Find the zigzag line. It's right here. So take out a writing utensil. I wouldn't recommend that you use a marker because it'll bleed through. So make sure that you have this zigzag line. I know. And I would put a line right underneath hydrogen so that everyone understands that hydrogen is our element that makes you go, Is it a non-metal? Yes, it actually needs to be on this side. Okay? But it kind of dresses like a metal. It acts like a metal in many times. So hydrogen is kind of like both. So we put it on the metal side because it kind of acts like, its personality is more like a metal. All right, that zigzag line is the most important line of all because everything to the right of the zigzag line will form anions. They will take electrons, Marie. Everything to the left of the zigzag line will form cations. They will give electrons. Using our analogy, guys, girls. Okay, so you're not allowed to write anything on your periodic table unless I tell you to. So if you've already written those things, erase. Now, I'm about to tell you to write. You're allowed to write what I tell you. Are you ready? Go to this first column and put a big fat +1. Because everyone in that group will tend to lose or gain. Lose. I know that in math, +1 means gain 1, but in chemistry it means lose a negative thing. And if you lose a negative thing, what do you become? Positive. Okay? Everything in the second column will be plus 2. Plus 2. Last column, 0. Those guys or those gals never react. That's why I call them the nuns of the chemical world, because they don't react. They're not that way. Just like real world, nuns are just not that way. All right? Everything in this next to the last column is minus 1. Minus 1. That is if it's on the right side of the zigzag line. And here comes the zigzag line, so this next one is just going to be for the first 4. Negative 2. Next one over. Negative 3. Everything, these 3 are positive 3. So either you put plus 3, plus 3, plus 3, or find some way to show that everything, that those 3 are plus 3. All right. Tin is found right here. Tin can be either plus 2 or plus 4. Lead is right below it. Same thing. Plus 2 or plus 4. Mr. Marino, does this mean that some of these can vary in how many electrons they lose? Yes. Why? You're not mature enough to understand. You're not. I'll let you survive next 9 weeks, and then I'll let you know. Yes, sir.
Is that 0 by the noble gases, like why they don't react?
Yeah, they will neither give nor take. They're completely happy with. And why are they completely happy the way they are? You're not mature enough. I'm not going to tell you. Maxine, what?
So if it's plus, if the column with hydrogen is plus 1, that means it loses 1 electron, and if hydrogen is only
Well, hydrogen itself can be either plus 1 or minus 1, depending on where it's located in the formula.
But if it loses an electron, isn't it just a proton then?
That's right. Good. All right. Over here. Plus 2. Plus 2. Asterisk. Asterisk. Plus 2, asterisk. Plus 1, plus 2. Right below it, plus 1. Next up, nickel, plus 2, plus 4. Cobalt, plus 2, plus 3. Iron, plus 2, plus 3. All the other elements have various charges. On the left, they're all plus. On the right, they're all negative. I'm not going to give them to you because I gave you the ones that 99% of all the formulas will have. And if you don't have it, then I have to give you a very important piece of information. A Roman numeral. Manganese. I did not give you the charge on manganese. So what if I was to say it's manganese 2? So what is the charge on manganese?
2.
Plus 2.
What if it were negative?
No. Negative,
You wouldn't.
I wouldn't give you that.
Okay.
Negatives don't have 2 possible charges.
Yeah, okay.
It's always the same. Any questions so far?
Can we write that in there?
No. All right. Now, let's deal with the asterisk. Because God gave us mercury in order to make the lives of chemistry teachers harder. 2 types of mercury. There's mercury 1. Yes, put this over here. I think you have some space there. Put a little asterisk there so you know where the asterisk goes. No, that I just expect you to know. Mercury 1, Mercury 2. So the symbol for Mercury 1 is Hg2 plus 2. And the symbol for Mercury 2 is Hg plus 2. Okay, that doesn't make any sense. Why does Mercury 1 have 2 mercuries and Mercury 2 has 1? Okay, first of all, I've already told you this, but the Roman numeral doesn't tell you how many atoms you have. The Roman numeral tells you its charge. So Mercury 2 has a plus 2 charge. Okay, Mr. Moreno, but why does Mercury 1 have also a plus 2 charge? Okay, this is what's a little hard to understand. Here we go. Mercury 1 is actually Hg plus 1, just like you would expect, okay? But Mercury 1 is one of these people that can't stand to be alone. Mercury 1 will not be alone. So in nature, Mercury 1 always comes with a twin. I like to think of it as Siamese twins. You know, they're interconnected. So Mercury 1 is one of the Siamese twins, and the other Mercury 1 is the other Siamese twin. But together, they're kind of like a unit. So together, there are 2 Mercury 1s, and each of them has a plus 1 charge, so what's the total plus? Plus 2. So Mercury 1 is a Siamese twin. It comes 2. You can write this on the paper. Erase it or mark it off, because if I find that you have written something in there that I have not given you permission to write, I will take up the periodic table, and right now that periodic table is critical to you. Without all those things on that periodic table, you cannot do what we're going to learn to do next. So from now on, if I was to take up your periodic table, that would be a killer for you. All right? Allison, I have set the ball. Monday, you will understand why I said, hey, I just set the ball beautifully for you to strike it on Monday. Monday, we're going to take this, what I gave you as a foundation, and we're going to use it to score some points. All right?